So the problems on the sixth chapter, that is probability and the random signals. So first problem is draw the Venn diagram of following. So what is given here? It is x is 1579 and y is 4567. So what is Venn diagram? Venn diagram is basically used for representation of the sets in a diagrammatic form. So the Venn diagram for the sets, we write here Venn diagram for sets x and y can be represented as we can say this as x, it is 1 9, this is y, so it is 4, it is 6, and common is 7 and 5 and 7, so it is 5 and it is 7. Okay, now Venn diagram with subsets we draw here. With subsets, so we draw here diagram. So here this figure shows it is A and B, 1, sorry, it is B, it is 4 and 5. Now this figure can be represented mathematically as A is what? It is 1 2 3 4 and 5, and B consists of only 4 and 5. So as elements 4 and 5 are the part of both sets, so it does not contain element. We write here as element 4 and 5 are part of both sets, and set B does not contain any element that is not a part of set A. We can say that set B is subset of set A. Set B is subset of set A. So we draw here Venn diagram with mutually exclusive sets. Draw here. So this problem is up to this. This is the second part. This is one example for with subsets. Okay. Now we see Venn diagram with mutually exclusive sets. So mutually exclusive set can be represented as, it is A and it is B. It is 1, 2 and it is 3. It is 4 and 5. So here set A and B do not share any common element. We write here set A and B do not share any common element among them. So we can write this as A is 1, 2, 3 and B is 4 and 5. So in this way we can draw the diagram for Venn diagram with subset and with mutually exclusive set. Now we will see the next problem. Draw the Venn diagram. Draw Venn diagram for following sets. So A is 1, 3, 5, 10. B is 3, 4, 5, 6. C is 4, 5. D 4, 8, 9 and S is integer between 1 and 10. Integers between 1 and 10. So we will draw the diagram for this. First we draw for A. So A is 1. Okay, next 2 is not present. Okay, and 3 is present between A and B, so we draw here B also. This is B. In B it is present 3. Then 4 is present between B and C, so we draw here C and here it is 4. Then 5 is present between, oh no, this is D actually. C consists of only 2 elements, 4 and 5. So 4 is present between B and D, so it is B and D, and we draw here C also like this. It is 5. C consists of 4 and 5. So this is C. Okay. Now next is 4, 5 complete. 5 is present between B and C. Okay. Then next is 6. 6 is present in B only. So here is 6. Then 7 is not there. 8 and 9 present only in D. So it is 8 and 9. Then 10 is present only in A. So this is the Venn diagram. Next problem. From a well, sniffed pack of card, two cards are drawn simultaneously. At random. So what is the probability that they form a king ace combination? So first we write down the number of ways in which solution, the number of ways is which two cards can be drawn from 52 cards. So we write probability for this. It is n is 2 cards are drawn from 52 cards. So it is 52 factorial by 2 factorial into 52 minus 2. So we solve this and we get it is 1326 ways. So these are the ways. Then number of ways is which one king can be drawn from 4 king. So we can write this as n case from 4 king 1 is drawn, so it is 4 factorial by 1 factorial into 4 minus 1 factorial. So it is, by solving it we can write it is 4. Now next is number of ways in which one ace can be drawn from 4 aces. So it is from 4 1 is drawn, it is 4 factorial by 1 factorial into 4 minus 1 factorial. So its value is again 4. And the next is the probability. Hence the probability that two cards drawn from the pack are king and ace, and it is given as probability P is king and ace. So it is n. So we have already find this value. It is 4 into 4 by, so it is 0.0120. So this is the answer. So So this is the probability that the king and ace combination can be formed. So this problem was asked in exam for 6 marks. Next problem. The outcome of an experiment is an integer whose value is likely to be any integer in the range let a be the even that I is odd and let b be the event that that I is divisible by 4. So find probabilities of events A, B, C, AB, AC and BC. So here sample space S is 1, 2, 3, and 12. A is 1, 3, 5, 7, 9 and 11. B is 3, 6, 9, 12. And C is 4, 8, 12. So these three conditions, we can find this value by given this condition. So we can write probability we have to find. So it is 6 by 12 is 0.5. For B it is 4 by 12, as it is divisible by 4, it is 0.33. And P of C is 3 by 12, it is 0.25. So 3 and 9 are common between A and B. And probability of AB is 2 by 12, it is 1 by 6. It is nothing, it's common, so it is empty. So probability of AC is 0. And next is BC. So it is 12. So probability of BC is 1 by 12. So this is the answer. In this way we can solve the problems. Next problem. A box contains red and blue balls. When two balls are drawn, without replacement, the probability that both are red is 1/3. So find smallest number of ball. In box. So first of all, let us consider the total number of balls in box is X. Now number of ways in which two balls can be drawn from the box means n. So n is equal to C2 of x. It is x factorial by 1 factorial x minus 2 factorial. So it is x into x minus 1 by 2. So the number of ways in which two red balls can be drawn from x of r red balls is. So nr is C2 x of r. So it is nr factorial by 2 factorial into nr minus 2 factorial. So it is nr into nr minus 1 divided by 2. Now probability of drawing two red ball is probability of drawing two red balls is nr by n. So it is x of r xr minus 1 by 2 x into x minus 1 by 2. What is given? Given that p of r is 1/3. So 1/3 is equal to xr of xr minus 1. This is equation number 1. Now to get two red balls, minimum number of red balls must be 2. So we write here to get two red balls, minimum number of red balls is 2. Therefore x of r is 2. So equation 1 becomes 1/3 is equal to 2 into 2 minus 1 by x into x minus 1. So x into x minus 1 is equal to c. So x is equal to 3 or minus 2. So we consider x is equal to 3. So minimum number of balls in the box is 3. We write here, therefore minimum number of balls in box is 3. Next problem. If A and B are two events such that P of A is 0.3, P of B is 0.4 and P of A is 0.2. So we have to find the values of first one, P of probability of so first is P of PA plus P of B minus P of, so it is 0.3 plus 0.4, its value is 0.5. Next is P of A bar by B. So it is P of A bar B by P of B. We can write this as P of A bar P of B divided by P of B. Now here assume A and B are independent events. We write here assume A and B are independent events. Independent events. So P of B get cancelled. It is P of A bar. Therefore P of A bar is 1 minus P of A. So it is 1 minus 0.3. It is 0.7. Now third is, now from equation, that is from above equation, we can conclude that P of A bar by B bar, it is P of A bar 1 minus PA, that is 0.7. And the last one, P of it is P of A bar plus P of B bar minus P of A bar plus P of B bar. So it is 1 minus 0.3 plus 1 minus 0.4 minus 1 minus 0.2. So it is 0.7 plus 0.6 minus 0.8. So its value is 0.5. So this problem was asked in exam. Now next problem. In the experiment of rolling a dice, find probability of occurrence of 4 if it is known that even face has appeared. Even face has appeared. So this problem was also asked in exam. Now the sample spaces are 1 to 6. So we write here sample space is 1, 2, 3, 4, 5 and 6. And probability to get any number is 1 by 6. So we write here probability to get any number is 1 by 6 and probability of getting 4 is 1 by 6. So as the occurrence of 4 and occurrence of even faces are two mutually exclusive events, we write here occurrence of 4 and occurrence of even face are two mutually exclusive events. So this problem was also asked in previous exam. So in this way we can solve this problem. In the next lecture we will see more problems related to the probability.